Hello everyone, myself Archana Priya. Today our topic is current electricity. Current electricity. This chapter will gives you a lot of information regarding our daily life, how the electrical appliances are used, and even there is so much of things to learn in this chapter where it gives you so much information. Now, electric current. Here we will be studying about definition of the current and what are the properties of the current. Next, even I can say characteristics of the current. Now, drift velocity. Drift velocity, here we will be studying what exactly the drift velocity, how the drift velocity will be occurred and formulas, and we have a few problems in this and we will be studied about that. Now, Ohm's law. Ohm's law will show the relationship between a potential and current. Next, electrical resistance. Electrical resistance will be derived from this Ohm's law, and we will be knowing how does the resistance will be depending on the material and on which factor it will be depending, and we have the few problems regarding the resistance too. And electrical resistivity. Here we look into the resistivity. There is in different materials there will be a different resistivity, and we will come to know how does the current will be resisted by the material. So that is about the electrical resistivity. Next, VI characteristics. VI characteristics, even I can call it as Ohm's law characteristics. So just now I told Ohm's law is a relationship between a potential and current. So here you are going to study about that characteristics. Non-ohmic conductors which doesn't obey the Ohm's law, that is called as the non-ohmic conductors. Here we are going to study what are the properties and which condition the Ohm's law will be obeyed and in which conditions it will be failed. There you are going to study about the non-ohmic conductors. Next, about the color code resistance. We have few particular color code for the resistor to identify how much it can be resist the current. So based on this you have a formulas and you have problems where you can enjoy the problems like anything. Next, electric current. Before going to start the electric current, we know that all the basic things is made up of an atoms. An atom is made up of proton, neutron, electron. So excess of body in the excess of body is called as a charge, or even I can say charge is a unit of a matter. By coming for a current, the rate of flow of charge is nothing but a current. So the rate of flow of charge means the charge should flow in a cross-sectional area in unit time. Then we can say the current. We can define the current like that. That is nothing but the rate of flow of charge is nothing but a current. We have one more thing, that is an instantaneous current. When the rate of flow of current is not steady, means if it is varying, then we call it as instantaneous current. That is nothing but we have a formula, I is equals to delta Q by delta T. So charge we are representing by Q and time we are representing by T, and current is I. Now the SI unit of current is ampere. Next, a small unit of current, that we can say we are measuring the current in terms of a small unit. Example, microampere. Micro value is 10 to the power of minus 6. Then even we can measure the current by the milliampere. So that is nothing but milli value is 10 to the power of minus 3 ampere. So we will be measuring the current even in the small unit, that is a microampere and milliampere. But your SI unit will be ampere. And dimension formula of current. Dimension formula of current we will be always represent with the square brackets, and here we have written A, or even we can write it as I. So how we can say 1 ampere? When 1 coulomb of charge is flowing in a cross-sectional area in unit time, then we can say it as a 1 ampere. So we will be having the CGS unit for coulomb also. So 1 coulomb, for charge also we have the SI unit, CGS unit. 1 by 10 is electric multiple unit. 1 coulomb will be equals to 1 by 10th of the electric multiple unit. And second will be as usual. So we can write as 1 by 10. Now we know that coulomb per second is nothing but ampere. Electric multiple unit by second will gives you biot. This will be the CGS unit of current. This will be the CGS unit of current. Where coming for CGS unit of Coulomb is that will be equals to 1 by 10th of electric multiple unit. Next, we come to know that how does the current will flow in the cross-sectional area. So if the cross-sectional area is the conductor is irregular, the cross-sectional area, if the current is passing from that, so the current will flow uniformly in all the cross-sectional area in the conductors. So it will flow same in all the cross-sectional area. Then if the cross-sectional area is small, the current will flow very fast. If the cross-sectional area is less, the current will flow very faster. If the cross-sectional area is large, then the current will flow very slowly. So this is about how does the current will flow in this cross-sectional area. Next, we come to know that whether the current is a scalar or vector. Now we know that, so the current is always opposite to the electrons. The current will be flowing always. How does the positive charges will be moving? In that direction only the current will be moving. The direction of positive charge is nothing but the direction of current, and always it will be opposite of electrons. Now, but even though we are considering the direction of current, we cannot say the current is a vector quantity, because whatever the direction it is showing, it's not a true direction. Now it doesn't obey the vector parallelogram law also. Now you can consider the electricity as a scalar, or even you can consider as a tensor quantity. You can see the two current. So one is passing, I1 is passing here, I2 is passing here. We are reaching at this particular point, and the resultant will be I is equals to I1 plus I2. So whatever the current is passing and it is reaching particular time, so or reaching particular point where your I will be equals to I1 plus I2. Whatever the angle may be, it can be a 90 or 100 degree, whatever the theta may be. So finally that I will be equals to I1 plus I2. Next, charge is conserved. So charge will be remain same in the conductor. At one end of the conductor, what will be the charges? After the other cross-sectional area also, the charge will be same. Example, if you are considering, when I connect the conductors to a battery, the battery is a source of energy. So it gives the energy, charge will utilizes the energy and will reach to the one particular end. So because of the gain in energy, the kinetic energy will be more, or I can say the velocity is more. It just utilizing the energy, it is gaining the energy. So the charge will remain same at all the time. So charge is conserved. Current different in situations. So we know you are human beings, we will be differently we will be behaving. Example, in house we will behave different, in classroom we will behave different, with friends we will behave different. So we will be behaving based on the situations, correct? Even a current will be behaving based on the conductors, electrolytes and semiconductors. In conductors we can see the motion of electrons. In electrolytes we can see the motion of positive and negative ions. Semiconductors we can see the motion of electrons and holes. This is about the characteristics of the current, or I can say an important note about the electric current. Types of electric current. One is direct current, one is alternate current. Direct current, which has a unidirection, which never changes direction. That is nothing but your direct current. If you consider a graph, we can see V versus T. You can see which is parallel to the time axis, means which is going, which is never changing its direction. So this is about the direct current. Alternate current, which will be flipping its direction, it will be changing its direction. Where you are seeing the graph V versus T, you can see a graph over here. From here to here it completes one cycle. Off of the cycle it is positive, off cycle it is negative. So this variation, the change in direction, is nothing but your alternate current. So next we are going to discuss about the problems regarding this electric current. Sir? Sir? Listen. Thank you.